just see if you guys can figure out, using your tables, see if you can come up with answers for the shaded areas here. Yeah, we'll just do that. Okay, so take like take a minute, see if you can figure out what these numbers are. So, you know, shaded area. Okay, what do we have here? 0.1492, is that what we got? So we can say probability that z is less than negative 1.04 is 0.1492. Or, so when you look it up, you're going to go to the row, negative 1.0, and the column, 0.04, right? And we're going to find 0.1492 there. Okay. How about everyone so far so good? Okay. And then what about over here? So the shaded area. So I would have 0.9452, right? So we would find the area to the left. So we can say probability that z is less than negative 1.6. We would look up this value and we get 0.0548. Okay, so probability that z is greater than negative 1.6 is going to equal to 1 minus 0.0548, which is going to be 0.9452. Okay, because the total area has to add up to 1, so if I have, you know, a little over about 5.5% over here, you know, then that means on this side I'm going to have 0.9452. So that everything adds up to 1. Okay, you know, here's a shortcut, and you don't have to use the shortcut. The area to the right of any z is the same as the area to the left of the negative of z. Okay, so in this case we were looking up, we want to know what's the area to the right of negative 1.6. The area to the right of negative 1.6 is the same as the area to the left of positive 1.6 because it's symmetric. Okay, but that's a shortcut, and if you're not comfortable with that, don't worry about it. Okay, but I just want to kind of throw that out there. All right. Is this okay? Huh? Okay. I'll give you guys a second to get that written down. Okay, let's so let's put this into the context of maybe an actual problem here, okay? So instead of dealing with z-scores, we can say I'm going to look up what is the average weight of a, I don't know, what's a neat animal? Nobody cares. Okay. All right, we'll say average weight of a tiger. All right, what do we have? What? This is huge. Okay, let's do Bengal tiger. Okay, average weight of a Bengal male tiger, 490 pounds. Okay, I have no idea what the standard deviation is, so we'll just say, okay, so we'll say mean weight of male Bengal tiger is 490 pounds, okay? And then I'm just gonna make up a number, standard deviation of the weight of male Bengal tiger. We'll say 35 pounds. Okay, and don't quote me on this, just making this up here. All right, so based on this information, and we'll say the weight of tigers is normally distributed, or follows the normal distribution. Okay, so we'll say based on this information, what proportion of tigers weigh over 500 pounds? Okay. So what we have here is that we've got the mean is 490, and I just made up a number, and I said the standard deviation is 35. Okay, this number could be very wrong, but we'll pretend that we know that the standard deviation is 35. And so I'm asking, based on this, what proportion of tigers weigh over 500 pounds? Okay, so if I were to draw a picture, I would draw a vertical line at 500. And basically, I want to shade in the area to the right here. Okay. And I'm asking, how much do I have shaded over here? Okay. So, what do you think the first thing we need to do is? We got to turn 500 into a z-score, okay? So the first thing is turn 500, which is the weight in question, into a z-score. Okay, so what is the z-score for 500? Yeah, we would do 500 minus 490 divided by the standard deviation, 35, okay? And then so, you know, the numerator would be 10 divided by 35, and we get 0.2857, okay? Now, when we look up this number in the z-table, we have to round off to 2 decimal places because the z-table only carries 2 decimal places. So we round to 2 decimal places. And now we have z equal to 0.29. Okay, and then so the next part is find the area. So we want to know what is the probability that z is going to be greater than 0.29. So to do this, we're going to, what? We can look up 0.29 and we get the area to the left is what? 0.6141 is the area to the left, right? So area to the left of z equal to 0.29 is 0.6141. So the area to the right is going to be 1 minus that. and I have 0.3859. So what proportion of tigers weigh over 500 pounds? Our answer is about 39%, 0.3859. So a little under 40% of tigers. Is that okay? All right, let's try another problem here. Okay, we'll say same thing. We'll say the mean weight is 490, standard deviation is 35, and here the question now I'll say is I'll ask what percentage or what proportion of tigers weigh between 450 and 500 pounds. So the way we're going to calculate this is I'm going to have a I'm going to take the everything to the left of 500 I'm going to subtract off everything to the left of 450. So we're going to say if this is the area that you want, what we're going to do is this minus this. Okay, we're going to take this area minus this area. Does that make sense? Okay, to get the area in between 450 and 500, we're going to say find the area to the left of 500, find the area to the left of 450, and then we're going to take the difference, and we'll be left with the area in between. Okay, so do we know the answer to 500? We already do, actually. We have z is equal to 500 minus 450. I'm sorry, not 450. 500 minus 490 divided by 35, and we said this is z is equal to 0.29, and that gives me the area. Probability that z is less than 0.29 was 0.6141. What do we do over here? We did the same thing. 450 minus 490 divided by 35. And I get negative 1.14. And so the area over here at z less than negative 1.14, that is 0.1271. So that means this piece right here is going to be 0.6141 minus 0.1271, the area in between, area to the left of here. And so the area in between 0.6141 minus 0.1271 gives me 0.487. Questions? Or are we all good? Great. Okay. Well, if I may, I'm going to flip the slide to the next page here. Okay. And then we have something called the inverse lookup of the normal distribution. Okay. And so we could say, you know, what is the z? What z is associated with the 30th percentile? Okay. So what does it mean to be in the 30th percentile? Yeah.
It means that 30% of the people in your class.
Okay, yeah, so if you're talking about a test score, which is probably the most common context where you see percentiles, like you take the SAT and then it tells you like your score was this and this is your percentile. If you're in the 30th percentile, then that means 30% score lower than this value, okay? Or, so in this case, that means I'm over here, and I want to know what is this z, what z here, what is the z here that gives me this area to be 30%, or closest to what? 0.3000. Okay? So can you guys tell me what is the z that gives an area closest to 30%? So you're looking in your table and you got like point. So you look at negative 0.5 and you have some values that are very close, right? You have 0.3050, 0.3015, 0.2981. Okay? And so 0.3 would be in between these two values, okay? And so we just have to make a call. Which one is closer to 0.3? The negative 0.52, right? So 0.3015 is the value in the table that is closest to 0.3. Okay, so that means, so z equal to negative 0.52 is the z associated with the 30th percentile. Okay, so what is this z? This z is equal to negative 0.52. Is that okay? I'm hoping this looks good. Everyone's good? Yeah, question. Why is it negative? Because when we look for 0.3 in the table here, it takes us to the negative side of the table, okay? Because the 50th percentile is where z is equal to 0, right? Yeah, and then so to be on the 30th percentile, we have to be below the mean of 0, meaning that our z is negative 0.52, okay? So yeah, anything below the 50th percentile is going to have a negative z. Anything higher than the 50th percentile will have a positive z. All right, are we okay with this? Okay, so then let's apply this a little bit further, okay? And let's still use the tiger information, okay? So we'll still deal with male Bengal tigers, okay? So male Bengal tigers, all right, so again, the mean is 490, and the standard deviation is 35, okay? So now the question is, how much does a tiger in the 30th percentile weigh? Okay, how would we answer this question? Okay, so we know the z that's associated with the 30th percentile. Okay, we figured that out up here, and we said the z associated with the 30th percentile is negative 0.52. So that means the tiger in the 30th percentile will have a z-score of negative 0.52. Okay. How do we get a z-score? We're going to do x minus mu divided by sigma. We know what sigma, mu and sigma is. Okay, so whatever the weight of the tiger is, when we subtract the mean and divide by 35, we're going to get a z-score of negative 0.52. So then solving for x, what would we get? We get negative 0.52 times 35 is equal to x minus 490. And we get x is 490 minus 0.52 times 35. And that gives me something else, all right? 490 minus 0.52 times 35. I get x is equal to 471.8. This is the mean weight, I'm sorry, not the mean weight. This is the weight of a tiger in the 30th percentile. Is that okay? All right, so let me give you kind of just a problem to work through. Make sure we understand this. Okay, so we'll say I have no idea. Average weight, okay. Let's look up these things. Nah, okay. All right, so let's deal with the female tigers. So the mean weight is 310. Okay, so we'll say female tiger, the mean weight is 310, and we'll say the standard deviation, maybe I'll say it's 30 pounds, okay? So I'll say, how much does a female tiger in the 80th percentile weigh? All right, so go ahead and try this out. So the picture looks like this, so that you have 80% over here. You want to figure out the z, and then you want to go from a z to a weight. So I'm going to go ahead and just pause the video here so you can, what do you call it? Work through it. Okay, so as I was walking around, a lot of you guys doing great. Some of you still working. So basically what we're going to do is we're going to go to our z table, and we want to find what is the z that gives me an area closest to 0.8, okay? And when we do that, we look and we get 0.7995 appears here and 0.8023 appears over here, okay? And so between these two values, the one that's closer to 0.8 is 0.84, okay? So our z-score is 0.84. Okay, so you don't want to use z equal to 0.8, okay? Z is not 0.8, but it's the z that gives me an area of 0.8, which is z equal to 0.84, okay? Yes, question? How did I get 0.84? So again, I'm going to my z table. I'm looking inside here for the area that's closest to 0.8. That area is 0.7995. 0.7995 corresponds to the row where its z is 0.8 and the column is 0.04. So my z is 0.884. 84. Okay, so my z is 0.84. So I'm going to say z is equal to x minus mu over sigma. All right, and so I have 0.84 is equal to x, the weight of the tiger, minus the mean of 310 divided by 30. Okay, so solving for x, I have 30 times 0.84, x minus 310. So 310 plus 30 times 0.84. Okay, and I got 335.2. So how much does a female tiger in the 80th percentile weigh? 335.2 pounds. Okay, and that's what we have for the normal distribution. Okay. Okay. One thing to note about the normal distribution is that the normal distribution is continuous. Okay. So the probability of getting exactly a particular value, the probability of getting an exact value is 0. Okay. Okay, so if we write, what's the probability that z is equal to exactly 0.4, this probability is 0, okay? But what we can do is probability is z is less than 0.4, and we would look that up in the table, and we would get 0.6554, okay? And this is also equivalent to what's the probability that z is less than or equal to 0.4, which is also 0.6554, okay? So, whether it says less than or equal to, it's for the normal distribution, because it's continuous, it's exactly the same. So that's just a note. So, what's the probability that something ends up being exactly this? So, what's the probability that a female tiger weighs exactly 335.2 pounds? The probability that a female tiger weighs exactly 335.2 pounds is 0. Okay? What's the probability that a female tiger weighs less than 335.2 pounds? And the answer to that is what? %, right? That's what our picture says, okay? We got 335.2 because that's the 80th percentile, so what's the probability that a female tiger weighs less than 335.2 pounds? 80% probability. Are we okay with this? All right. Okay, and then so the last topic we're going to cover today is the binomial distribution. Okay, so earlier on I said, let's say we play roulette 3 times. Okay, and I ask, what is the probability you win 1 time? Okay, and which implies you lost 2 times. Okay, and we said the probability of winning on red is equal to 18 out of 38. Okay, so what is the probability you win 1 time? Well, there are 3 possible outcomes, 3 outcomes that are included in winning 1 time. And those outcomes are you win the first, then you lost, then you lost. The next outcome is lost on the first, but you won the second, and you lost the third. And then the last one is you've lost, and then you've won. Okay. Are we in agreement here? Okay. And so what is the probability of getting this exact sequence? So the probability of this sequence would be, I'm going to do 18 out of 38 times 20 out of 38 times 20 out of 38, right? Because the probability of winning is 18 out of 38 and the probability of a loss is 20 out of 38. Okay? And the probability of this sequence would be 20 out of 38 times 18 out of 38 times 20 out of 38. And then the probability of this last sequence would be 20 out of 38 times 20 out of 38 times 18 out of 38. Also okay? If we look at these, because multiplication is commutative, meaning that the order doesn't matter, each of these, each sequence has the same probability. Which is, you have to win 1 time, 18 out of 38, times 20 out of 38 raised to the 2 power. Okay, so each of these have the same probability. The probability of winning raised to the number of times you've won once, and the probability of losing raised to the number of times you've lost twice. Okay, and because there's 3 possible sequences, I'm going to just slide this over so I don't have to go to the next slide. Each sequence has the same probability. Okay, there are 3 sequences. So the total probability is that we add all of these together and we have 3 times 18 out of 38 to the 1st power times 20 out of 38 raised to the 2nd power. Is that okay? Okay, so let's try another one out. Okay. So let's say you play another game of chance. Okay. This is supposed to be, so you spin the wheel, okay? And, you know, you got the kind of the little ticker, and then we'll say 4 pieces are red, okay? And then we'll say 6 are green, okay? And we'll spin it 4 times. Okay, what is the probability? And we'll say all equal probabilities. So what is the probability that after 4 spins, it landed on green twice? All right, so I'll list out all the possible sequences. To get to green. Okay, you can have red, red, green, green. Okay, and I think that covers all possibilities. Okay. What is the probability of this this first sequence? Or any of the sequences, really? So we'd have, well, here, let's look at this one here. Green, green, red, red, okay? What's the probability that we get green? Uh, 6 out of 10, right? So the probability of getting green will be, so here, maybe we'll write this. So the probability of green will be 6 out of 10 or 0.6, okay? And the probability of not green or red is going to be what? 0.4. Okay? So this sequence is going to be 0.6 squared times 0.4 squared. Is that okay? And all of these will have the same probability. So the total probability is going to be 6 times 0.6 squared times 0.4 squared. And I don't know what that comes out to be. I guess we can calculate it. 6 times 0.6 squared times 0.4 squared. And that probability is 0.3456. It's kind of interesting coincidence there. All right. Okay, so the kind of the general formula here, okay, is that when we're dealing with a binomial, okay, so in a binomial situation, is you're going to repeat the same trial n times, okay? So we're playing roulette 3 times. We're spinning the wheel 4 times, whatever it is, okay? Each trial has only 2 outcomes. Success, which we arbitrarily label success and failure. So it could be you win the roulette or you lose roulette, okay? Or the wheel spins and lands on green, or it doesn't land on green, which means it landed on red, okay? So each trial has only 2 outcomes, okay? And then the probability of a success on one trial is P, okay? And we are interested in X successes, okay? And so for our kind of our wheel problem, we said spin the wheel 4 times. So that means n is equal to 4, okay? Indeed, we only have 2 outcomes, green or not green, or green or red. The probability of a success, probability of getting green, is 0.6, okay? And we are interested in getting 2 greens. So here we have x is equal to 2, and I'm sorry, p here is equal to 0.6. Okay? And so the probability of getting x, the probability of getting 2 greens after spinning it 4 times is going to be 6. This is the number of combos, or number of arrangements, times 0.6 squared. This is times p raised to the x power. Okay, the probability of a success, we need to get 0.6, and it needs to happen 2 times raised to the x power, okay? Times the probability of a failure, 0.4 raised to the 2 power. So this is going to be multiplied by 1 minus p, the probability of a failure, and this has to happen n minus x times, okay? Because we have a total of n trials. Does that feel okay? All right, so the piece that's missing is how do we figure out the number of arrangements? Okay, and so the number of arrangements is determined by what we call a combination. Okay, you have permutations and combinations, and so these are combinations, okay? And so we have something called choose. All right, and we can say n choose x is equal to the number of arrangements of x trials with x trials and with n trials, and x of them are successes. With n trials and x successes. Okay, so we would have something like 4 choose 2. This is 4 trials, 2 successes. Okay, so 4 choose 2 is equal to 6. Okay, it can also be written, so n choose x can also be written as NCX or N over X in parentheses like this, okay? You probably have a button on your calculator with it. You might have a button, so on my calculator it's over the division sign and it's called NCR, okay? If you have a Texas Instruments, you might have to hit the math or probability button, okay? And then you would use kind of the arrow keys to find NCR, okay? And so let's say, you know, if we spun the wheel 10 times, and we want green 5 times, how many arrangements are there? This would be 10, choose 5. And so on my calculator, I would do 10, and I hit Shift, divide key to get NCR, and it looks like a big C there. And I write 10, choose 5, and I hit equals, and here it says 252. It says 252 possible arrangements. Okay? Because you don't want to have to be like, you know, green, 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 red, 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 and then, you know, this would be a miserable existence, right? To try to figure out all possible arrangements, okay? There would be 252 of them, and the calculator can do this calculation, okay? I guess I'll put the formula here, but I would say rarely does anyone actually use this formula. Everyone just uses the calculator button. I assure you. All right. See, this is the formula. You know, exclamation point meaning factorial. So, if your calculator can't do the choose function, you know, I can answer that question. You can ask me like. What is 8 choose 3, and I can tell you that on Testy or something like that. Okay, so you know, probability of getting X is going to be N choose X, P raised to the X, and 1 minus P raised to the N minus X. Okay, or binomial. All right, good luck.